Okay, so how do we start at the beginning? Well, what is the beginning? Well, the beginning is the atomic structure of particles. And what are they made of? What are atoms made of? What is the nucleus made of? This has been the real issue. They've been trying to smash nucleuses into little bitty tiny bits, as small as they can get. And they can see these particles, these muon neutrinos attached to electron neutrinos, a black and a white particle basically. And then every now and then they can see these showers come off of the white particle, and the muon black particle does not change. Now, I will show you this in our experiments. And what I am going to tell you right now is that the new theory that I have is dipole electron flood theory. And what is an electron? It's right there, a muon neutrino attached to an electron neutrino. The muon neutrino is dark matter, and it is also gravity. Never been seen before, except for these high energy collisions, and they don't know where they came from because there's so many particles they can't see them. We started with light. We started with this photon, and I can show you those photons, and then I can show you them accelerate, and then I can show you them turn into electrons and showers, which is these exact here. And actually, as a matter of fact, my good friends, here it is right here. This is the concussion zone, where these particles, and let me show you the particles in a second. Those particles normally were attached, a black and white ball. At the venturi, the black cannot compress and the white can. So the white showers through here and the black goes around, and the black is the muons. Now, how did we get to see this? How was this done? How did we create this reaction that separated the black from the white to make the electron showers, which is the white, and left the black balls unaffected, and they come back over here to reattach? Now, here's how we did it. Okay, my friends, what I'm going to show you was all completely done with a cell phone and a pulsed red construction laser and a tiny little venturi made literally out of nails. You can do this at home. What I'm going to show you is cold fusion on a desktop. If you did this correctly, and I'll show you how to engineer it. And then there's all kinds of different special little devices that you may be able to add or configure in certain ways that could enhance the performance. Now, this is strictly pulsed red laser from that measuring device. It's a Bosch GLM 15. It goes bip, 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 and every time it does a bip, it is a particle or a ball of particles, but they are light particles, so they're the tiniest particles that exist, basically. And they don't even know if they're particles or not. I could show them they are, and I show they are a wave. Now, how could it be a wave and a particle? Which it is both. And they say it's a duality, and I have no clue why. Well, the particle is a magnetic particle. It's nothing more than a magnet, which every magnet has a field around it. So as it comes through the air, every other particle has a field surrounding its electric nature, because everything is electric in nature. Every single thing there is made of these electron dipoles. And just as they come two together, make photons, and then they get bigger and bigger from there. 1839 make what we would call protons, and a bunch of them are bigger and bigger and bigger. It makes snowballs, and they become stable at these different sizes, and these are atomic weights. And atomic weight is 1839 electrons make one atomic mass unit. So when you get up here into like copper and all this stuff, I mean, you're up into 100,000, 200,000 particles. I don't know what it is. I'm just guessing at this point. But for every proton, it's not one proton. So you come over here let's take oxygen. This is supposed to have 8. Well, that's 16,000. It's not 8. It's 16,000. And I can't remember. I have to look at. But my point is, for every proton is 1,839. For every neutron is 1,840, because that's just adds one more electron to make it neutral. 1,839 is a charged particle. It's not neutral. It's not even. They have more positives than negatives. So at 1840, it becomes neutral. It says, I'm good. I don't want any more. I don't want to give any away. I have just exactly the ones I need to complement the other ones that I have. Stay away. I am neutral. That's what they're calling a neutron. Now, I don't know if that exists or not, because I think it's just more of a bigger ball of electrons in a soup of other electrons. Because the nucleus, as I say, in the electron flood theory, is a pile of electrons in a number that becomes stable. And when it becomes stable, it becomes stable. That core is tight, man. That's that they call it the strong nuclear force. Absolutely strong. That black ball wants to hold on to that white ball just as tight as it can hold. And I have some stunning new pictures that I haven't had a chance to really look into. They've taken field images. This is energetic particle images. And what is an energetic particle? They're electrons being slapped, spanged, scrubbed, heated, boom. And the harder you do it, the more energy it exhibits. Now that's just red laser light. That's pretty powerful. Being able to take, and this is what we took it with, was the cell phone. And this was, Rod Warren did this over in Australia. But I have the exact same stuff. But the pictures he did are absolutely fabulous. He spent thousands, literally thousands of hours. Now, and this is the phone, and he's still using this today, Galaxy S3. And, it's the same phone, and of course he's got his there, and I got my stuff here, same stuff. Now, what are we looking at? And why does this camera phone take these, and you can do it in your own phone now, and the new phones, whoa! I'm going to show you that picture of that magnetic field anomaly, because it is staggering. And when you see the polarity, because it's dipole flood theory, is what everything is made of dipoles. That means there's a black and a white of everything. And when I say that, you see this? I think I showed it to you before, but let's just go back so you can see what the black and the whites are. And they come in green, and they come in red, and they come in blue. Like this is a green. You see it, the black and the whites? And it's the 2p, 2h, 2p's, 2h's. Particles, holes. Now, that's an electron. That's an electron, back to back. They're nothing more than 2-bar magnets, and they have a weight, and it's very, very small. It's like 0.00055 atomic mass units, something like that. They don't even consider them to be anything, the electrons. They're nothing. Now, that's a green one, and they're pretty energetic compared to the red ones. And here's the way the red ones manifest themselves. You would never see that particle coming into that form. You see up here? These are not in line with the Venturi. You see back here, you don't see anything at all. You see these, they're in line with the Venturi, but they're too far away from the Venturi to stack up to make this absolutely gorgeous 2p2h particles. Back here, and then up in here, they're a little concussed, but you don't see them doing this. This is just phenomenally fabulous. And then when it hits the Venturi over here, it's explosion time. And at that point, they do the separation, which is exactly what CERN says is the muon neutrino, electron neutrino. At this point of concussion, which is where they create Cherenkov radiation, the muon goes on its way as the black ball, and the white turns into the shower. So that is fission. They separated. I mean, you can't deny this. They separated. The black came away from the white. They come back together here. That's fusion. Right in here is nuclear energy. So I think we should be able to harvest that. And I have a very simple design And all of these things are off-the-shelf components. Lasers, you see, that's a laser. This is this laser right here. Bip, 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 bip. All right, and I think it's got to do with the pulse. And I know 100% certain it's got to do with the Venturi. This has to be tuned exactly correctly. And this is what we need to talk about, and I need to explain. But this would be the device in its fruition. You would have the laser. Whoops. Oops, there goes my neutron. Hold on. The neutron on the floor. All right, we got the neutron back. Here's your laser. Bip, 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 bip. All right, there's your little Venturi. Just absolutely passive. No additional energy added whatsoever. It forces the fields to crush. The blacks separate from the whites. Right there is where you harvest. And then they want so desperately to get back to their black counterparts, we force them to come down through, and they'll turn anything, motors and heaters and air conditioning and lighting and anything you want to do with them. And you'll be able to carry them around in there it goes. I'm telling you, gravity happens almost every time you drop something. Isn't that amazing? You know, the amazing thing is they don't know how it happens. What a world. I'm not kidding you. The standard model of physics right now does not account for this. So anyway, oh man, it just gets funnier and funnier by the moment. Now, so we got to get away from the standard model, and I showed you we're going to go to electron flood theory. But seriously, I'm not kidding you. With this increase of power, this is all raw electrons. That's just absolutely staggering amount of energy that we should be able to create. It's 200 times the input. And if you look at the increased value, let's go back one more time. I like to go over things many times because people don't pay attention the first time, maybe the second time, maybe the 30th time. All right, here comes the particle. We saw a standard wave, and maybe you didn't pay attention to that one, so let's go back to that one. All right, what do we see in there? Very little to nothing. All we're seeing is that like bip, 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 and because it's a magnetic field with the particle in the center of the field, its glowy particles push these other ones out of the way, just like a jet fighter does. No difference whatsoever. Now, it's a jet fighter not breaking the speed of sound. It's just getting everybody out of the way. Get away, get out of the way, I'm coming through. And when I come through, I'm going to get hot. So this one here is glowing. That's why we see it glow. It's push to shove back. The pusher is usually the ones that gets really glowy. And you know, as close to the pusher as it is, they get glowier, and the further away they get less glowy. Until you're so far away that they don't feel the impact anymore. Now, what happens if we put that through a Venturi and accelerated that light? Well, first of all, we showed that Einstein wasn't right. That's my favorite part. Now, the second thing we show is that we increase the value of that particle, which I showed you as this little four-banger. Well, you never see it. You would never ever see it. And even here, you don't really see it. You see it sort of blurry looking. And then all of a sudden, as it gets about over to here, it shows its actual physical four-banger particle nature. And they're exactly equal. Well, I don't know if they're exactly equal, but they're very similar looking balls. White, black, white, black. Now, here, they come apart. That's fission. And if you can just think, stop, clear your mind, stop. Stop. I said stop. Clear your mind. Look at this here. What do you see? Again, clear your mind. What do you see? I see an atomic explosion. Literally, and I am not kidding you. That is an atomic explosion. That is a nuclear explosion on a desktop. All right, what did we start with? Just give it some thought. Like I say, clear your mind out. Don't lock it up. We accelerated light. So forget about Einstein, forget about Hubble, forget about Bohr, forget about all of them, because they weren't right. A light is a particle Light can accelerate. Light can slow down. Hubble's speed of light being consistent and not coming to us, that's totally wrong. It's not the red shift, everything's going away so fast, and it might be, but it's certainly not 100%, because light is slowing down as it comes. And the more stuff that's in front of it, the slower it will get. It's just a matter of impact. Push to shove. They say space is a vacuum. Absolutely not. It's packed with these particles. 100% packed. Every light particle is a particle. I'm showing they're particles. Particle is a particle. If light is light and light is a particle, the universe itself is a soup. It's a literal soup of particles. Now, are they all electrons? Or are they all photons? No, absolutely not. There's bigger ones, there's smaller ones, there's isotopes, there's dust, all kinds of things out there. But primarily, it's going to be light. And that light is what impacts our atmosphere. We're going to go into that too. We got so much to go over that this is just a start, but I need you to understand, light is not a wave of nothing. And this is a single slit. And that's why interference patterns are repulsion patterns. Light does not want to be next to each other. The white particles say, get away from me. Get away from me. All you white ones, get away. The black ones, yeah, come on, come on, come on. Well, the black one, I think, really is the one that comes after the white. That's the way I see it. The black one is a real sucker. it wants to be attached to these white ones absolutely, desperately. That is where your strong nuclear force is in the attraction of the black to the white. Now let me show you these field pictures I got. Absolutely stunning, and I don't really know what to make of them yet, but I can tell you what, they're stunning. All right, I'm going to give you an explanation of why particles charge up when they push against other particles. Now, what are we looking at here? This is the actual photon coming through the air. This is glowing because it's concussing with particles that are in the air. So, and everything in the air is a magnetic particle. This is coming and forcing, and anytime you force any electrons into any other particles that are electrons, you create push to shove. Now, if you arrange them in the correct way with blocks of magnetism separated, pushing against blocks of copper, you can end up creating a motor. So, what is this? This is a motor. And if you take a motor and you spin it, you can feel it go click, 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 click. You can feel it go snap, snap, snap. And that's you hear it? That's the magnet that surrounds it, the magnetic field, pushing against the copper windings. There's copper windings in there. And when they push, the copper has all this excess electrons. It's absolutely stunning. I'll show you some of the pictures of copper interacting with magnets. It's unbelievable. Well, I'll show you right after this. It's just you won't even believe it. It looks like supernatural. But there's so much electrons, when the copper hits the magnetic field, it just goes, and that's what's happening here. It's filling this up with energy. All right, and I can prove this right now. I'll prove it with this meter, and I'm on DC voltage, and inside this is a regular motor, and if I spin it one direction, I can make it go positive, and I spin it in the other direction and go negative. Watch. So I am spinning this. Normally you would put electricity into these wires. I am spinning it and making the wires put electricity back out. Virtually all this stuff works in or out. If you put electricity in, it makes it run. If you spin it yourself, it makes electricity out. That's why water mills and all these things, solar powered, whatever they call them, windmills and all that, that's how they create electricity. They spin motors, and then the motor shoots out the electricity. Watch. You see it? Minus 8 something. Boom, in that direction. Minus almost nothing. Minus boom, boom, boom. If you get the right spin, and you know, if I keep it spinning, it'll keep putting out electricity. See it? Now, if that's all minuses, now I'm going to go the other direction. See, pluses, no minus anymore. See it? So that's how a motor works. Now, see it? One way in, one way out. It depends on which way you're pushing against the magnets. So we're going to learn all this, and this is what happened on this one. This one's filling up, and then all of a sudden it'll go blip, and this one, which is empty, goes to the front, and this one goes to the back. Now, they with all of this, they don't understand anything about the nucleus, and I'm going to show you they don't understand anything about it. The thing that just came out today, I couldn't believe it, about the neutron. They're still trying to work it into the standard model. The standard model is gone. There is no such thing as a gigantic, singular, big, huge proton. They know they can smash these into little tiny bits. And then they say, oh, well, yeah, there's a strong force and a weak nuclear force and a gluon and a fermion and a boson and a muon and electron neutrinos. And I mean, it goes on and on and on. You can imagine the words. Tetraquarks now they got. I mean, everybody thinks they found something. But all they found was chunks of these particles that had a different configuration. But they're fairly stable in the very, very base particle. In other words, this photon is they see it, the 2p2h, they know this is they call it an elementary particle. It's not. Elementary is this one and that one. These are the two elementaries that I can find. Although we did find something that was very strange, and I can't put any name to it whatsoever, and I can show it to you, but it was a killer. I don't know what it is. But anyway, these are the elementary particles, because I know they can come apart. You saw them come apart. So we know that light can be these particles, and I'm telling you what, right now, light makes everything. Plants eat light. They eat light. They eat light, and that's how they grow. And virtually everything is a transfer of energetic value. Now, that energetic value is absorbed, and it actually ends up creating matter at a certain point. And we got to talk about that. That's a whole nother issue, because this is where it really gets crazy because they talk about everything was made at the Big Bang. No, absolutely not. Matter can be created right now. I could prove to you right now that bacteria can take elements of heavy metals that are toxic and turn it into gold. As long as it's a bigger element, you can reduce it down to one of these more stable forms down in here. So they're taking some kind of nasty stuff up here that's some nuclear this and that, and bringing it down to gold. Now, you could take mercury, I think you could take mercury and bring it down to gold. Or, bring it down, because mercury, well, anyway, that's alchemy. And that stuff was real. That stuff was real. You just have to know how to deal with it. There's pressures. There's resonance values. There's temperatures. And then there's catalysts and enzymes and bacteria, basically. And you say, oh, bacteria, come on, Roger. Well, I'll show you bacteria. Hold on. All right, I want to be certain I didn't mislead you, because my statement was not clear. We cannot create matter. We can only create different atoms, which right now they say, once it was created, you can't change it. You can modify, you can add a little of this, a little of that, but you can't, all the copper there is was created in the Big Bang, and all the gold there is was created in the Big Bang. That's not true. We can change these. They used to call it alchemy. You can make gold, I believe, from mercury, because all you're doing is taking out an extra electron or a batch of extra electrons and bringing it down. Now, bacteria can do this. All right, see, this will take us to a lot of strange turns, But these bacteria eat toxic metals and they poop gold nuggets. So they're taking their little particles out and reducing these heavy toxic metals down to gold because they've digested a part of that nucleus of that particle, creating a new element. And they say, you go, oh, this was all made at the Big Bang, or you can't make any more of this stuff. No. Bacteria makes everything. They make as much as you want if you have the right bacteria. Okay, just so you can support yourself if anybody says this is not right. This is University of Wisconsin-Madison, but this is about guys from CERN. And this is 2014. They realized that they could use these same pocket phones, and this goes back to that era, Samsung Galaxy S3. This is the one right here, and this Rod's still using this today. He claims this was one of the best, or I guess he claims it's the best he's used, and he's tried a bunch of different stuff. And they say right here, it says that the app basically transforms the phone into high energy particle detector, and that's what they want to see. They create these secondary particles called muons. Now, if we don't see high energy, you don't see anything. That's why when the laser comes out and you see it's kind of lazy laser. Well, it's making a wave. You can see it. It's high energy. It's pretty high energy. But when it hits the accelerator, yikes, that's when it goes insane. But this proves that we are okay talking. And they say that it's the same principles as very large experiments. All right, so and that's 2014. Now, wait till you see this. Let me show you what I just got the other day. Okay, I just got these pictures not long ago from Rod Warren, who is the one that does all the other pictures. These didn't come from Rod, they came from his nephew, Dylan Carpenter. And he just used a regular phone. I guess it's a pretty fancy phone, but I don't know what app he has in there, but it's picking up these polar fields around particles. And I don't have much detail to talk to you about, although I do understand field effects, and these are fields. And there's our black and white particles, the dipoles, and every one of these particles is a dipole, because space will create dipole effect because it's in a not a vacuum, but it's in a swirling soup, not crushed like here on Earth. You can't see particles here on Earth the way you can in space. And the Russians did some experiments in 2015. I worked with their data. I didn't work with the Russians exactly. They were very forthcoming with the data, though. And it showed exactly what can happen. And they literally created a black hole in space, because the particles all the white ones will push away and the dark will go to the center. Now, as they're spinning, though, that wasn't spinning. That was just in a vacuum chamber. As they're spinning, they take on a different effect. They turn into dipoles, which are just magnets. Just like when I spun the motor, we could see the magnetism being pushed into the meter. So this is I understand this. Now, here's the thing that kills me right here. You see how uniform these fields are? The big black ball, and it's bigger than the white. It just seems to be. But then over the top of the moon, some of the white ones are bigger than the black. I don't know what's going on the moon, why they should be in front of the moon. Like I say, I have no big news about this. But I can tell you this, when you see blue, it's more energetic than when you see this color. So this is either energetic because it's working against these fields, or it's pushing these fields out of the way and going this way. I don't know. However, I can tell you what, this is the one that really excites me, because I'm almost sure that this is Venus. Now, why does that excite me? Well, normally you're going to see a very well-defined black ball and a well-defined white ball. Here you got this glowy, fuzzy, whitey, and then you got black mixed in with white. Now, is this glow just covering some of the blackness, or is this literally spinning backwards? It should spin in a certain direction, where we saw those particles before. They were nice and round little balls. This is a different thing. Now, is this black? Is this an because Venus spins backwards. That's why I'm kind of excited, because the other ones, I'm seeing other things. He sent me a bunch of other pictures, and I didn't see anything like this. You see that thing? I just don't know exactly what's going on here, but I wouldn't expect to see all this glowy black, you know. In other words, the black particle is not supposed to emit. It's not supposed to absorb. It's not supposed to radiate. It's not supposed to emit. And then I say it's not supposed to concuss. And it shouldn't grow. Well, that's growing as far as I'm concerned. It looks like it to me. Is this spinning backwards? We found a particle that doesn't follow any of the other particles' rules. And I'll show you that particle. And these are all fields of the particles I'll show you in a second. But remember this glow, it looks like it's being, I just don't know. This is a fight going on here that just, I never saw before. You see how these are all nice and uniform looking? And this is just as, and Venus is 850 degrees or more. And every time you heat something up, it glows more. And this is glowing like a spotlight. And I can't prove that this is Venus, but I can, you know, he didn't do any doctoring of this. He just took this picture with some kind of fancy app or what. I don't know how he got it. I have no clue. But you can see these fields are overlapping with other fields. These are all, the new CMOS, the way they work, the pixelation, is whatever energetic value they pick up in these tiny, that's why they say megapixels, gigapixel, I don't know what they call them now. But if there's enough of them, each one of them will have its own absorption of energy, and then they send it through the process to the process. Oh, that's yellowish, that's a little oranger, and they could be right next to each other. I mean, with no way for the human eye to ever detect the difference. And then they make a pattern of it, and that's what he's got here. And the same thing Rod has. This phone here, I mean, it's got to have something to do with the CMOS ability to sense, first of all. So whatever, and they call it thin film sensing now, and I'm sure they did back then. Its ability to sense is fabulous, and its ability to process is also fabulous, and it appears to me, and that's the abilities of this phone, even though it's old. And look at this thing, though. I mean, think about the abilities going on here. Yikes! And think about what is going on here. And here's the other ones he sent. Here's a couple other ones. Yeah, see that? That's the moon, apparently. Again, I don't have this. Look at this thing. This is all the CMOS background in the phone. And that's how it can light up. You see, every one of them is a dipole. Every single one of them. Everything's a dipole. And that's why and they're in space. And that's why they show as dipoles. Because everything in space is moving. It's rubbing. And when you rub anything through magnetic particles, and space is saturated with magnetic particles that are just like magnets, and as you run things past them, they concuss, and as they concuss, they push the black to the back and the white to the front, or vice versa. Now, that's why they're all dipoles in space. You can't see them on Earth that well because of the crushing effect of Earth. You see the black and the white? And again, he just was taking pictures. Very strange stuff. Now, I was thinking this might be the Pleiades. Oh. Isn't that cool? Look at those fields. These fields are interacting with each other at long distances, it appears. And look at this. This is a lot of whitish area here, and then you got this blackish area over here. So there's some interaction of the stars or planets or whatever they are. I don't know what they are. But their fields are affecting each other. I mean, these fields are obviously affecting each other. Now, these fields are blowing back. I don't know. There's so much to look at now. it just blows my mind. And I get this stuff every day. So there's so much to look at, and I'd like to get this out and have people start to investigate it themselves. And this is what this course is all about. I want you to be able to understand this stuff and do this with your own cell phones. He did tell me the settings he had it on. I'll see if I can find it. But I don't interact with Dylan or Rod hardly ever at all. They basically just send me pictures of what do you think, and then I go to work. and sometimes, I'm telling you, I've been working on the stuff Rod sent me for 6, 7 years, maybe more, and I still find things every day. Oh, well, not every day, but pretty damn near. Things you never looked at or thought about. As it starts to build brick by brick, eventually you say, wow, that's how that happened. Wow, that's why that happened. Oh, now it's coming clear. You know, I mean, it's like one of those detective shows on TV. All right, what you got to remember now is Hubble was wrong, Einstein was wrong. You can speed up light, you can slow down light. This speeds up, it slows down. It's a particle. All right, it has a field around it, creates a wave. All these things are fully not understood. And these are the two particles that make up the electrons, which make up everything, and they are light. Well, light comes from the sun. They don't know that the light is in here in space. These are particles everywhere, completely saturated with particles. We're scrubbing through them. The sun's scrubbing through them. That's why it's 2,700 degrees out here, 2,700 degrees, and only 100 on Earth. Millions out here, and only 7,000 on the sun. It's the scrub. All of these things are not understood at the moment, so it's a complete start over as far as I'm concerned. Remember that, because we have no idea where we are in space. If space is loaded with these particles and light can slow down and speed up depending upon what it hits and it's bumping against, one over here could be coming at us through a whole batch of stuff, and one over here coming through nothing. We would think this one here is you know, very close, and this one's far away, and it could be just totally the opposite. We have no idea where anything is in space at this moment. But the close-up things in our solar system, probably yes. Outside of that, we have no idea. Totally lost. Okay, so according to my theory, what did we learn today? We learned that the proton is not one gigantic big particle. It can be broken down. This is fully understood. They just didn't realize that it's all made of the same small particles, the muon and the electron neutrinos, which we would consider to be an electron, but nobody's ever seen a black particle. Now, and I show the black particle and the light accelerating, so we know that light is a wave and it has a particle and it can accelerate. So we got an issue with Einstein, we got an issue with Hubble, issue with all that stuff, Bohr and the whole 9 yards. And this is light, and these are the particles, 2H, 2 holes and 2 P's particles. And they can flip up and down. See, the white is up and the white is down, and they charged up. I showed that, I believe. And these are the Higgs fields as they begin to reattach out here. In between here, we can have raw energy. These spikes of are just absolutely stunning amount of energy, as you can see. It's quite obvious. And that is also pretty well understood by CERN and Fermilab, only they just can't get their heads around the fact that we did it with this kind of equipment, and we know how to do it now, and you will too. You'll be able to do this at home. I'm serious. You may actually be the next one to be able to create free energy. Pay attention to when I show you these particles and what they're made of and how they work and how they interact, and how there's a ton of them that make up a proton, not just one. There's 1,839. You add one more, it's a neutron, 1,840. Now, photons are only 2 of these particles back to back. Electrons are what we always thought for electricity, lightning, static. Yes, absolutely. But nobody ever knew there was a black particle attached to it. That really detracts from its energy. When we separated that particle, the black one, look at this. Look at what happened. That's just phenomenal. And this is a single slit. We got so much to talk about. Now, you might be able to do this. I'm very, very serious. Somebody out there will do this. Now, whether it'll be a big corporation, I don't know. but there should be no patterns on this. I've been showing this for 6 years. The Venturi, and the Rod Warren is the one that created the Venturi. Total by accident, he had no idea what he did. And it was actually hard dragging information out of him. He was trying to do a slit experiment. And instead of using a flat plate, he used a round, and they were literally nails, absolutely just nails. And he had them so perfectly split that it kept the black from going through, but the white could get through. This is what we need to work on, is this Venturi construction. And you may be able to create free energy. Because the solar panels, they're available right now. Lasers are a dime a dozen. It's just getting the Venturi correct. And then however we can harvest that energy into a collection device, which they're doing now. They're collecting out of solar panels right now. So there's no problem with the collecting it and dividing it and changing it into AC or DC or 50 cycles, 60 cycles, 120, 220, whatever you want. So once we get it from here, it's off the case. Everything else is ready to go. And lasers are here. Solar collectors are here, although we can put them on steroids by working with transition metals. That's why I show all these colors. Those are colors of transition metals. They have deep absorptive, I think they call them the d orbitals, which are capable of grabbing a hold of a lot more electrons. And I think that is what we need. You cannot regulate them in like a PNP or an NPN transistor type array device as well, because they take on too many states, I think. You know, all of this stuff got to be really looked at, but we want it to take on so many states, all these different states, because that's where the electrons are hitting harder and softer and bigger. You know, we want them to take them all in, and we want them to flow down through our device. Now, let me show you the copper, because this will blow your mind. This is why motors work. It's when magnetic fields interact with copper coils, or lots of copper. A coil makes a small amount of copper turn into a big reactive amount, because the coil wrapped in iron, they wrap them around iron, and it creates a big field. So you don't need a ton of copper here. But if you just had a big block of copper, it would do the same thing. So when a magnet hits it, it'll just stop it like it was. Where do you see this? This is just phenomenal. But if we can get to this point, well, somebody's going to do it. Let me put it that way. And I'm going to help you if you are interested. And in the videos, I will show a little more detail about what this device should look like and what Rod did. And somebody's got to do this. We need free energy. That's the only way we're going to save this planet. This planet is in desperate. And humanity, just think of the suffering. People are going to be starving, and they're just starving now. If you had free energy, that's free lighting, free heating, free air conditioning, pumping water for free, putting out forest fires with the equipment, just walking around with them for free. You know, I mean, you know, there's a lot of equipment, but the power, let's say power for free. Driving cars, planes, boats, trains, anything you want for free. The energy source. Huge reduction in expansion gases, because these don't expand. You push the electron through, it drives a motor. It might heat up a little bit, but you're not going to get the expansion like you do now when you burn coal to make a generator generate electricity. Absolutely not. Nothing like that. Whoa. Way different. And that's the only chance we got right now. And I am pointing to you people because I am too old to make this happen. If I was a younger guy, I'd be really slamming the streets right now and this would be done. But I just can't do it. I am too old to do this. I could you know, I couldn't see it through, and I don't like to not see something through. I want to see what I see through is somebody taking over and straightening this mess out. That's what I will feel like I saw it through. I can't do it myself. They say, oh, why don't you just do it? Why don't you just do it? Why don't you call this guy, call that guy, talk to this guy? I can't get through to anybody, first of all, because I'm on spam lists. They don't want to talk to me because they don't like the things I say, because it upends all their physics that they're charging the kids thousands and thousands, put them in debt for their whole lives to learn these things that a lot of it is not true. If you're going to learn how to build something, or metallurgy or something like that, electronics, that's all good as long as it's physical and like the stuff I show you. But say, I want to go for theoretical physics about how neutrons and photons and, outer space is. They don't even know that space is a vacuum. I'm not kidding you. The people at Fermilab don't even realize space is not a vacuum. It's incredible. They think it's just carbon sitting around outside holding all the heat in. We're scrubbing through that. We have 2,700 degrees out there because it's the ionosphere. That means electrons. That's what ions are. It's scrubbing through all the particles that are out in space. So we need to really change things, and you guys are my only hope. That's why I'm doing this course and this for academia.edu. And they claim to have 170 million people subscribed to them. So if we can get to just a small percentage and start to understand the situation we have and what our possible solutions are. Because I have another possible solution with hydrogen and oxygen in the water breaking down, using some really cool little techniques that I can relay to you as we go forward through the school here. Because everything is made of electrons. In electron flood theory, there is nothing but electrons. 1839 makes a nucleus basically of a hydrogen. A helium, I think, ends up being, instead of like a few protons, it ended up being 7,350 electrons, something like that. And that's just helium. That's 7,000. And this gives us all of the elegance of biology, because this is all biology. All this stuff is in your body. These are transition metals. These are what's in your blood. They move things back and forth to keep them in an unstable condition, believe it or not. Your body is unstable right now. Not a single molecule in your body is stable. And it's taking on things and giving things up. That means instability. I can't hold this anymore. I'll take it. I'll get it out of here. Oh, you need something to eat? I'll bring it. Oh, you got somebody attacking you? I can take care of that. Your body is just an unstable mess of particles, and the things that keep it from just going into terribleness is bacteria, believe it or not. That is what runs your entire body. You see all the places you go when you start understanding chemistry and electrons and everything? And bacteria, that's a whole nother issue, but I'm sorry to keep going off on these little tangents, but this is where, if you don't have a broad spectrum of abilities, which is biology, which is chemistry, which is physics, which is geology, which is history. If you don't have some of all of that, you don't have any of it, because then you just say, oh, this is what I know. Oh, yeah, you got to talk to Bobby about that. Oh, no, I don't know anything about that. Well, and this is what I get from everybody. I try to never mind, I won't go through it, but it's distressing that it's become so compartmentalized that you cannot comment on somebody else's region of research. We will be broad thinkers here, stretching. All right, we will look at everything, and where it leads us could be just virtually anywhere, but we'll go there. All right, so I guess I'll probably wrap it up for today. This will be the first course. And I hope for now you understand what the particles are, what electron flood theory states, and that everything there is made of the electron. And the electron holds a particle onto it, which is called the muon, which literally is dark matter. All right, so next course, the next class will be just an extension of this, and we'll show how all of the different interactions that occur. Heat. What's heat? What's cold? What's darkness? You know, how does light really react? And what is the Schumann resonance frequencies that resonate down through the atmosphere? And what are the layers of the atmosphere? Why are there different layers? Why do we see different colors? What's the aurora borealis and australis? What are the telluric currents? I mean, we're gonna got a lot of stuff to do, my friends. And this, I see this as a lot of fun. I hope you do too. All right, I love you. Keep thinking. Come up with questions. If you don't understand something, figure out what you don't understand. Write it down. Make it concise. All right? Make sure you get a little journal for yourself if you're really interested. Because I'm going to tell you right now, physics is different than anybody realized. And if you're going to go to get a job somewhere, bring your manual in with you, your journal. Say, look, I took this, and here's what they said about, you know, because you'll also understand exactly what they're saying about the Bohr model and the Standard model. I can tell you exactly what they're saying. It's just not right. Everything is made of these particles. They're seeing bigger particles, and they're seeing enough of them, a frequency of them, to say, well, that has to be an elementary particle. So now we got leptons, we got quarks, we got tetraquarks, we got, you know, it just goes on and on and on. That's what they're all made of, and they're just little bigger pieces. All right? I love you. Next class coming up. Thanks.